Good morning. Good morning, everyone. My name is Andrew Carney. I'm a program manager at DARPA and ARPA-H, and I'm here to talk to you about the AI Cyber Challenge. So, to achieve technology truly indistinguishable from magic, we need infrastructure and software that is extremely robust, extremely performant, and extremely resilient. But in today's increasingly software-driven world, we heavily rely on projects developed and maintained by passionate, capable volunteers and donations. And this fuels our critical infrastructure. It underpins our daily lives. At the same time, that critical infrastructure is under constant attack by nation states and, to quote, unsophisticated cyber actors. That feels bad. And in general, how do we go from where we are today to this sort of what we can imagine, the sort of tech future and all the benefits of realizing that? I think sustained technological advancement is only possible with an extremely strong foundational tech stack. And the stronger we build that foundation, achieve that magic level tech. So a small example, Erlang OTP is an open source library originally developed by Ericsson and released open source in 1998. It's been under active development for a long time. It has an active community of maintainers. It receives support from a number of commercial companies, and it's software used in a variety of networking and telco appliances. Earlier this year, a critical bug in the SSH application was disclosed by university researchers. The maintainers rapidly turned around a fix and pushed it out within hours, at most like 36 hours, I think. It was super responsive. That vulnerability was introduced in 2014. And I strongly encourage everyone to look up the actual CVE and look at the code. It is trivial to find and trivial to exploit. It is literally, why bother with authentication? It's easy to find. There are so many techniques, so many tools that have the potential to find that bug in 30 seconds or less. And yet it existed in this actively maintained, widely used code base for over a decade. When this bug was released, Cisco, NetApp, a few other companies disclosed whether or not they were affected. There were a number, even today, there are a number of Cisco products that do not have patches available. 4 months plus between disclosure and the maintainers patching upstream and us actually getting a patch into the hardware that's used in critical infrastructure. Once again, this feels bad. And this is not anything against Ericsson, against the maintainers, or against Erlang as a language. I don't know. This is not a sustainable or tenable situation. We can't live like this. And so, in response to this growing need for better automated vulnerability discovery and remediation, DARPA launched the AI Cyber Challenge and has collaborated with ARPA-H to change the world. And as you will shortly see, we have. What is AIxCC? So this is a public competition to develop autonomous systems that can find real vulnerabilities and patch them effectively in source code. The vulnerabilities themselves are realistic. We've taken real open source software and developed synthetic forks and developed realistic vulnerabilities and inserted them into those synthetic code bases. So millions of lines of real code with novel synthetic vulnerabilities that have never been seen by any person or LLM before. So discovery is important, but patching is where we really change the game. So we wanted to reward teams and systems that could patch as effectively as possible. We see a lot of efforts on automated vulnerability discovery, and those are great. I love that. That's been most of my career. But what we need is to fill this gap in patch development, patch generation, in an effective, timely manner, because the scale of the problem is sort of beyond what we can deal with as humans. We have a lot of things to address before we get to that tech magic. And then to maximize the impact of this technology, if successful, we decided that we were going to release all the competitor technology, the finalist technology, open source. So let the world benefit, because to make ourselves safer, I think we need to make everyone safer. Like this is the way. A brief note on bugs versus vulnerabilities. So today we triage bugs or issues that are disclosed, that we find in our code, because we have limited resources to remediate them, to develop a control, to write a patch, to push that patch, to deploy that patch. It is labor intensive, time consuming. And determining the security relevance of a software defect is hard, maybe undecidable. So I really think, and based on my experience, and I think any of you that have done VR can I think agree, that what you see as a bug today could be a fantastic O-Day, like weaponizable tomorrow. Just give it more time, get the right person to look at it the right way, and you can find that kind of security kernel, pun intended, in that issue. So, but if patching is so cost-effective, so fast, so readily available that we don't need to triage, then the bar that we need for can be a lot lower. So in AIxCC, we reward teams that find reachable, triggerable bugs. We focused on security-relevant CWEs, things that are common issues that are used in the wild to exploit systems. But any defect in code is a defect we should be able to remediate. This is, we can focus on security, but we actually want an aperture that allows us to address any issue, because we need that performant, resilient foundation. So it's not just security, but this is a really good place to start. So we set the bar for if you could trigger a defect at least 1% of the time. If we throw it 100 times and it hits, it triggers at least once. That's good enough for us. That should be patched. That should be fixed. At the same time, we knew that the promise of sort of LLMs, the potential to analyze the semantics and the natural language of our massive code bases, the documentation, the context in which we use them, this field itself was rapidly evolving. Like, how do we capture what we need? How do we create an environment where teams can apply automated program analysis techniques in a really novel, world-changing way? So we started off the competition 2 years ago with partnerships from the frontier model companies. Google, Anthropic, OpenAI, and Microsoft have provided over $1 million in credits to teams to test and play with models as they've developed their automated systems. They've also provided engineering support, expertise on automated system development, which is also hard. There's a big leap between developing a program analysis tool for a person to something that's wholly autonomous, that can scale as you give it more compute, and that won't knock over and you can't just run it in you can't just restart it in a loop. Something that's more robust than that. Remember, robust, resilient, performant. That's what we need. So they have been super helpful partners in this. We also knew that to have the maximum possible impact, releasing the tools open source was a very good start. We also needed active engagement with the open source community, and so we've been partnered with the Linux Foundation, Open Source Software Foundation, or Open Source Security Foundation, and recently OSTIF, the Open Source Technology Improvement Foundation, as creating conduits to help maintainers and project owners deploy and benefit from these technologies. So last year at DEF CON, we got to talk about our semifinal event. This was the first time the teams were put to the test. They were given challenges they'd never seen before. They had no prior knowledge on the open source repositories we were necessarily, well, they had some knowledge on the open source repositories we were from. But we needed to see, is this even possible? DARPA attempts hard things all the time. That's part of the ARPA model. So if this was a non-starter, if just no one could actually do what we needed them to do, then we could go back to the drawing board, try again, redesign the competition, wait for the technology to evolve. Happily, the teams did some amazing things. Even with the resource constraints we provided, they were able to find and patch vulnerabilities in millions of lines of code across real open source projects. And one team found a real issue in SQLite that we got to disclose to the maintainers. Proof of life, amazing. So that set us on the road, and this is how the teams performed across sort of the different classes of vulnerability, their overall performance. We saw that there was a gap in the Java coverage that we wanted to improve, and we only gave the teams challenges in C and Java. The C performance was good, but we think it could be better. And the final 7, the top 7 teams, were a mix of university-affiliated and small businesses. These were folks, I'll say scrappy, I mean that with all in the world, like teams really both on the edge of the program analysis space, so trying to take on and adopt LLMs and these other technologies as quickly and as effectively as possible. So in semifinals, we had a pretty simple set of challenges. People had to prove that a bug was reachable, that they could crash a harness that was provided for that project, and then they had to show that their patch remediated the bug without interfering with the normal execution of that software. Because of how well the teams performed, we increased the complexity for finals significantly. We added more real-world challenge types that map directly to use cases that we see in the normal kind of software development lifecycle. We added different types of challenges, giving them a patch diff or maybe a full repo, scoping things differently, but once again, mapping to the real world. And then we added this bundle as a challenge, the idea that it's helpful if you can associate a triggering input with a patch and or a bug report. So these are all useful things in the real world, and we wanted to see if the teams could do this well. We consulted with critical infrastructure owners, maintainers, and government agencies involved in our critical infrastructure and came up with a set of open source repositories you see here, and this is what we derived our challenges from. Overall, over 54 million lines of code across these repos. So once again, as a reminder, this is how they did in semifinals a year ago. This is how they did this year. This is bananas. Yeah, well done. The teams were able to patch almost everything that they could find, every type of vulnerability that they could find, they could patch. Super cool. The Java performance, huge improvement. We also threw lots more classes of vulnerability at them and defect. So this was incredibly exciting. So these teams found ways to leverage the LLMs alongside traditional dynamic static analysis techniques in a way that was truly novel, innovative, and game-changing. This is so exciting. So to put the progress another way, they discovered nearly 80% of the synthetic vulnerabilities we inserted into the challenge problems. They patched over 60% of all of the synthetic challenge problems. And they did that faster than they did in semifinals. We did give them more resources, but this is massive improvement across the board. And it's not just based on model improvements. I can tell you that definitively. Ask the teams on how they use the models later, but it was not just the models got better. The teams figured out how to use this technology better, in more innovative ways. They also found way more real-world bugs, real vulnerabilities, that we are in the process of disclosing to maintainers still. We've spent the last month validating the final results, and part of that has been disclosure to maintainers. And so we will release all of this information publicly once it's appropriate to do so, and we've kind of finished the disclosure process with those projects. But this is awesome. So thinking about it another way, we gave them 70 known vulnerabilities. On top of that, they found 18 0 days. Of those 70, they were able to find most and patch very many of them. The average time to patch is under an hour, fantastic, despite us handing them a massive volume of code, 54 million lines. And in semifinals, they were very resource constrained. They had 4 hours of wall time, limited cloud compute, and $100 of LLM credits per project, so $500 budget total tops. For finals, we wanted to take resource constraints off the table as much as possible. So we gave the teams tens of thousands of dollars of ceiling to play with. And no team exhausted their budget. The total spend between all the teams in the final round was almost $360,000, and 82 of that was for LLM credits. And that got them nearly 2 million queries with the various models they used. But when we actually break that out, that's very reasonable per task success. So whether it was finding a vulnerability, creating an effective patch, validating or validating a bug report, or associating those items together, the spend was very reasonable. This is cheaper than the status quo is today. This is amazing. For anyone that, it can take a lot of time to find a vulnerability, and patching, if you don't know the project, there's a tremendous amount of labor that goes into this. So the fact that the teams were able to do this against these challenges for low hundreds of dollars, and this is honestly, this is a very conservative estimate. There are teams that definitely were doing this cheaper consistently. I've never been so excited by $152 in my entire life. This is awesome. So before we go any further, there are so many people to thank here. I'm not going to go through the entire list, but this has been such a massive collaborative effort from the get-go. We've had folks in industry, government agencies across the United States government, just small companies that all over the place. Making this all happen has been a monumental collaboration, and I'm so grateful to everyone here. And there are many people here that we couldn't even list, but just thank you. This was a big tent operation, and super excited to kind of keep moving forward with everyone. And now before we get to the results, we have some special guests, and I am super pleased to invite to the stage the Deputy Secretary of Health and Human Services, Mr. Jim O'Neill, and after him, the Director of DARPA, Mr. Stephen Winchell.
Good morning. It's really an honor to be here with you at DEF CON 33, not just as Deputy Secretary, but really as someone who's spent a lot of his career breaking things in order to build them. I didn't really come here to talk about cybersecurity policy, although it is important and I do work on it. I really came to ask for your help and to make the case for why the stakes have never been higher and the opportunities have never been greater. Let me start with the obvious. Our healthcare industry is driven by data. And like every data system, it has vulnerabilities. Escalating cyber attacks are disrupting patient care, stealing personal data, and destabilizing medical infrastructure. We must stare down this threat if we're to make America healthy again. Between 2018 and 2024, more than 650 ransomware incidents targeted our healthcare providers, compromising nearly 89 million patient records and causing almost $22 billion in downtime costs. Individual breaches can be catastrophic. The attack on Ascension last year affected more than 140 hospitals and probably cost between $1.1 and $1.6 billion in operational paralysis, lost revenue, and recovery efforts. These attacks, including ransomware and data breaches, have the power to grind entire health systems to a halt. By shutting down payment systems, blocking access to patient charts and prescriptions, and exposing private information. Health systems are among the hardest networks to secure. Unlike other industries, hospitals must maintain 24/7 uptime, and they don't get to reboot. They rely on highly specialized legacy devices and complex IT ecosystems. As a result, patching a vulnerability in healthcare can take an average of 491 days, compared to 60 to 90 days in most other industries. To address healthcare vulnerability, we need bold innovation at the intersection of AI, cybersecurity, and health. We need systems that you would find elegant, and only you can solve them. Many cybersecurity products, unfortunately, are security theater. We need assertive proof-of-work approaches to keep networks, hospitals, and patients safer. That's why over the past 2 years, HHS and DoD, through ARPA-H and DARPA, have led the AI Cyber Challenge to protect our nation's healthcare from cyber threats. The Trump administration knows that this is both a national security challenge and a tech opportunity. President Trump's executive order, sustaining select efforts to strengthen the nation's cybersecurity, calls for greater action to defend our digital infrastructure, especially in sectors most vital to the public. We brought together innovators from across the country to build next-generation open-source digital health security solutions. We've also activated support from major American AI companies, Anthropic, Google, Microsoft, and OpenAI, who made their tools and expertise available to our competitors. AI is now the cornerstone of cyber defense and national security. Through the AI Cyber Challenge, we can secure hospitals and preempt cyber attacks. Our AIxCC will accelerate discovery, unlock innovation, and most important, deliver real solutions to patients and providers faster. That's why ARPA-H has committed $20 million, not just to reward top teams, but to help translate winning solutions into real-world use. We need bold, rapid progress to close the cybersecurity gap in healthcare. This initiative is a powerful step forward. On behalf of ARPA-H and DARPA, I'd like to congratulate all of the competitors. Your work over the past years has been remarkable. You'll leave a lasting mark on the future of cybersecurity and of health. As Andrew just told us, in the past month, the teams identified 52 synthetic zero days in Java and C and patched 47, and they also identified 18 real zero days and patched 11. I understand the teams transformed over the past few years from skeptics of frontier models to fans. And I hope all of you will stay involved. HHS is building technology, and we're also hiring. America needs 10x engineers, data scientists, and AI developers to advance health tech, speed delivery, and reduce regulations and save taxpayer money. Please join us. If you want to solve hard problems and scale good solutions to protect people, consider working with us at HHS. I know everyone here has options, and we can't compete on price, but we really can on mission. Since January 20, we've deployed technology to drive innovation and transform health. For the first time, we gave FDA reviewers AI tools to speed approvals of new drugs and devices. We look forward to rolling out LLMs and other AI tools across the department and across healthcare. We've increased transparency by tripling the number of data sets at healthdata.gov from roughly 3,000 to more than 10,000 through our new HHS Open Data Plan. Our National Coordinator for Health Information Technology, Dr. Thomas Keene, is giving patients access to and control of their own health data by improving the interoperability of electronic health records. And here with us today, we're honored to have Clark Minor. After a brilliant career at Palantir, Clark became the CIO of HHS. He's sitting right here in the second row. Clark, stand up again. I want everyone to see you. There's Clark. Clark is leading the modernization of legacy AI systems for 65,000 employees and doing a great job. One of the greatest levers for better health and better prosperity is information. And in so many ways, Secretary Bobby Kennedy is opening the windows and letting the light flood in. He's delivering radical transparency about vaccine safety data and government operations. He's reimagining nutrition science to produce evidence-based dietary guidelines. And he's creating new pathways to conduct robust health research using larger and more diverse data sets. So come work with Clark and me. The problems are tough, the mission is urgent, and the impact is real. Secretary Kennedy has made health innovation a priority, and we're seeing results very quickly. Keep breaking things in order to make them better, and join us at HHS to make America healthy again. Thank you.
All right. First off, thank you, Deputy Secretary O'Neill and Dr. Roos and the ARPA-H team. Really appreciate all your help and support. As you all know, this is a joint operation between DARPA and ARPA-H, and as well as OpenAI, Anthropic, Microsoft, Google, who provided over $1 million of credits to the team. I just want to talk about a couple things before I get off the stage and actually get to the good stuff, which is some really amazing results. We're living in a world right now that has ancient digital scaffolding that's holding everything up. a lot of the code bases, a lot of the languages, a lot of the ways we do business, and everything we've built on top of it is all incurred huge technical debt over the years. And the reality is, it is a problem that is beyond human scale, and it's a critical problem that we need to solve right now. Andrew and I have talked quite a bit about this late into the night, and we're both really concerned. And this is one of the major efforts that we have to actually try to solve some of those problems in a way that's scalable, in a way that kind of leverages a lot of our strengths, American AI companies, ingenuity here in the United States, and also just really, really awesome people. So DARPA is absolutely really excited about this, and I must say of the almost 300 programs that we're running at DARPA, this is one of my very favorites. Even before I came to DARPA, I was a huge fan. But I want to talk a little more about what DARPA is actually doing in this space and how we're thinking about the problem. Right now, today, DARPA has 14 programs and over $650 million being invested in security for computer systems, for compilers, for eliminating weird machines, for provably secure code bases. These are all the pieces we need to make an entirely secure system and a scaffolding that we can build the modern world on that actually works. Yes. Thank you. The other thing I'll say is, that $650 million, who's it going to? I'm here to tell you it's going to the very best people. People in this room, small businesses, and innovators. 25% of our dollars right now are going to those companies, and we expect that number to actually go up during my tenure. So really exciting, and like I said, the magnitude of it, the diversity of the programs, and the holistic focus on these systems is what we're really driving towards at DARPA. So I want to shift gears a little bit and talk about AIxCC. There's not a whole lot else to say, really. People have already said all the really awesome things. Yes, 18 days, 11 patches, Java, C, really great performance across the board by all 7 teams. Amazing. But what I will say, a couple things that struck me, right? The first one is the vast improvement and the speed of improvement over time. The second thing that struck me is the amount of opportunity space that we still have to tap into. There's improvements in models, improvements in orchestration, and ensembling, improvements in specializing agents and training them in simulation environments, improvements in the simulation environments themselves. There's just so much that we can do. And we're already at 77%, right? So that's fantastic. The other thing that struck me is that machines are performing at superhuman levels already, right? Those 18 vulnerabilities or 18 zero days, maybe some people, given enough time, would have found them, but we're seeing superhuman performance already, both in the results and obviously in the speed. All right, I'll end with a happy announcement. So the 4 of the models, the CRSs, are actually going to be available open source starting right now. The other 3, yeah. No, I was actually just talking to my brother-in-law who's in the audience, and he said he can't wait to start playing with them, and I agree. With great power comes great responsibility, Zach. The other thing that I want to, is obviously the other 3 released in the coming weeks as well. And also, DARPA and ARPA-H have gotten together and put an additional $1.4 million in prize money into supporting the competitors in their application of these technologies that AIxCC has developed, these CRSs, into critical infrastructure relevant software problems. So we are continuing to kind of pour gasoline on that fire. We're now over $30 million, and this is just a huge opportunity for the community to have great new tools and for all of us to work together to secure that digital scaffolding and make all of our lives better, both for every American citizen as well as for the men and women in uniform who are out there on the front lines. So these are critical technologies for all of us, and automating them and scaling them is the future. So I just want to thank Andrew, the teams, and everyone else. It's really exciting. I can't wait to show the results. So thank you.
Thank you so much, DepSec O'Neill and Director Winchell. Sorry, I didn't want to be overly formal in this venue, Stephen and Jim. This is super exciting. That additional 1.4 million that ARPA-H and DARPA are contributing for is available for all teams, and we'll provide details shortly to them. So no results just yet. So this weekend, what can you do with AIxCC? So as Stephen said, some of the CRSs are already available open source. That's very exciting. Over in the AIxCC experience, we have the teams will be there to talk about their solutions and talk about them in depth in a way that they haven't really been able to, which is exciting. You'll be able to view competition data and artifacts that are not available anywhere else. You'll be able to see the generated patches, the generated proofs of vulnerability. You'll be able to see the interactions between the models and the systems. Some of these visualizations that we're running in the background will be available as well, describing the competition. There's a whole lot to look through over there that helps us examine how the competition unfolded, how the teams did what they did. We also have folks from critical infrastructure representing different sectors, talking about their specific problems. So please come to the AIxCC experience. And when you're talking to the teams and when you're thinking about the problems that yet remain, the teams really have so much more potential than what we were able to test in the competition. We picked what we thought were critical issues, critical elements that we could reasonably test and validate. But we know that teams can support more languages. We know that teams can work without harnesses, for example, or with less instrumentation. We know that teams can find more types of defects. So there's a whole lot of potential in all of these teams, and it's really amazing what all of them have done. So please come talk with us and figure out how, it's cool to see the data, but how you might be able to use these tools moving forward. Some more detail there. We will be releasing the competition data archive and infrastructure over the coming months, and there are ways to reach out to us, AIxCC@darpa.mil if you are a maintainer or an owner of a software project. Please reach out to us so we can start potentially collaborating, helping you integrate these sorts of tools into your system. And this is alongside our work with OSSF and OSTIF. Okay, we're close, we're getting there. So this is in alphabetical order. We wanted to highlight what the teams did. So Team 42 Beyond Bug had the most correct serif assessments. So bug report analysis, they were the most correct at. And they were the only team to score, they scored on our largest challenge repo, which was over 5 million lines of code. Very exciting, well done. Team All You Need Is a Fuzzing Brain had our first C real-world vulnerability in any of in the final round. And they were also able to score at least once in under 5 minutes in one of our tasks. Awesome. Team Lacrosse was extremely accurate with their proofs of vulnerability, and they discovered a real-world vulnerability that no other team discovered. Well done. Team Shellfish was the best at describing how their system worked, which is no small feat, to be clear. And this is true in general. These systems are very complex, integrating lots of automated kind of components, technologies. So that was super helpful. They also were extremely good at patching. Their patches had an exceptionally high passing rate. Team Atlanta had the most real-world vulns discovered, and they were able to, combine the most artifacts from the competition successfully and identify this proof of vulnerability goes with this patch, goes with this bug report. Awesome, well done. Team Theory was one of the most cost-effective. They spent the least per vulnerability patched, which was awesome. Their use of resources was awesome. They also had the most Java real-world vulnerabilities discovered. So well done, very, very well done. Trail of Bits, and I say this with love, Loch Ness Monster, that was my achievement name. They have a patch that successfully scored that was over 300 lines of code, which was the biggest scoring patch that we had. Awesome. They also scored on 20 unique classes of vulnerability. Well done. Excellent job. Okay. I would like to invite Deputy Secretary O'Neill and Director Winchell on stage to help me hand out the prizes to the top 3 teams. When your name is called, please send a few representatives up from your team and receive your award. Very exciting. All right. In third place, congratulations to Team Theory. Do you want to stand up maybe in front of the table? Because we couldn't move it, and I'll let them walk in front of you. Yeah, if you go up, they'll go up with them. Congratulations. Thank you. You guys are awesome. Thank you. Congratulations. Awesome. Thank you guys so much. Congratulations. In second place, with a prize of $3 million, congratulations to Team Trail of Bits.
Thank you, sir.
Congratulations. Congratulations. Guys were awesome. Congratulations.
Thank you so much. All right. Well done. Awesome. Congratulations. Well done. Thank you guys. Almost there. And in first place, with a prize of $4 million, this team exceeded in all but one category of challenge. They were the top performer in all but one category of challenge. Congratulations, Team Atlanta.
Congratulations. Congratulations. Congratulations.
Thank you guys so much. No jackets? So I'll leave. So this was the overall performance across the teams. Everyone did something unique. Every team found a unique vulnerability and/or class. And the teams have not had access. This is the first time anyone's seeing this data. And the teams have not had access to their own results yet, but they will get that shortly. They may have questions about their own kind of performance as well, but this is going to be a fun exercise we go through over the next few days. yeah, this was incredible. These teams did such an amazing job. Very, very impressed with everyone. So the world changes today. The systems that were developed by every finalist will be available, are either available now or will be available very shortly. They've shown that they can patch real software quickly, scalably, in a cost-effective way, and those tools are yours to use. There is no excuse not to leverage this flavor of automation, and it will only get better, right? This is the new floor. It will rapidly improve. So I'm super excited that we're going to get to warp engines and replicators and holodecks and autodocs and pick your favorite fictional universe. This is how we build that foundation. And I am super excited and very proud of all the work that's gone into this. So come join us in the AIxCC experience and figure out how we can take the next step to addressing these big problems. Thank you so much.